Hey everybody, today what we're doing is we're going to be introducing the course and doing our first lecture, and at the end we'll talk about what's due and what you should have done for next week. So let's get into this. Alright, so that's the opening. Hey everybody, I'm Professor S. This is SRA 365. Welcome, welcome, welcome. Like I said at the beginning, today is a really big day. It kind of sets the course for the whole course. We're going to be introducing everything, introducing myself, introducing how this course will work, and then I'll also begin with the first material, and we'll finish off by talking about what's due at the end of the week. So before I start introducing myself, let me talk about the rest of the teaching team. I reuse these videos, so chances are in a given semester there's not going to be the same teaching team from one to another. It's just people move on. The thing is like you will know the different ones based upon if they're commenting on your grades. If need be, you can reach out to them in Canvas. That's an option. As for me, I am a Penn State alum. I've taught a lot of this course at University Park, and I'm a huge nerd. I nerd out about a lot of different things, and like Star Wars, been into that, food. I eat a lot, and I continue to do it a lot, and I really like flannel. I'm not wearing any now, but I get into it in the colder times of the year. So you might see me wearing some flannel. I have quite the collection. Not to brag, but it's kind of a lot. Anyways, I think everybody should wear flannel. But anyways, let's talk about the course. So the course, you've seen the description before. This is in Canvas, and I pulled this from LinePath, so it shouldn't be new to you. The way that we're going to be learning about this, so it's statistics, but it's taking the next level from your Stat 200, right? And the way that we're going to be doing this is measuring your grade is with labs and exams. There will be 12 labs in this course. The lowest one will be dropped. There's 3 exams, and they will all count towards your exam grade. So make sure you do the best that you can. The thing is like each week we'll have one of those things. So it'll be either a lab week or it will be exam week. This happens to be a lab week. So you have to make sure you get the lab done for the end of the week. Okay? The labs make up 55% of your grades. Exam make up 45% of your grade. Adds up to 100. Smart, huh? Expectations. So I expect you to, 1, ask questions if you don't understand something. We try to be transparent with our grading. We try to offer different help throughout the semester. Like, for instance, these videos. I'm going to be doing videos for almost every week this semester. So I'm trying to help you. There's also text online, like on Canvas. Like, that's our textbook. And so I expect you to try. And if you don't understand anything, that's okay. The important thing is that you try to reach out to us and allow us to help make sense of it. We can help you. I will be posting office hours. I don't know if my teaching team will also do office hours, but I will have office hours posted. When you are watching this video, that link might not be available yet. Because usually the first week I'm still figuring out my schedule, so I don't know what it will be, but it will be posted, and there will be a link in the at least in the syllabus, that will go to a page that will lead you to a time where you can schedule a meeting with me. You can also send message through Canvas. Canvas is like one of the best places to send questions, and so at any time you can send a message, and just expect give me some time to get back to you. If you wait till Sunday, the Sunday that it's due, to ask me questions, you might not get an answer in time that for it to be due. So I encourage you to try to work through things in a timely manner, so that if you have any issues, you can ask them and we can answer those questions. So with that said, I expect you to complete assignments on time. Everything is pretty much due before Sunday, 11:59 p.m. Eastern Standard Time. It's in Canvas. And I also expect you to do your own work. Don't work with others. You can ask questions about different things, like, I don't understand this concept, that sort of thing, but you can't say, like, what'd you get for this answer? Now it's my answer, right? Also, can't use ChatGPT, can't use all other sorts of things. The idea is for you to learn this material, and you don't do it by copying answers. So make sure you do your own work. Okay? And please do it on time. So I have a late policy. There's academic integrity. We kind of touched upon the academic integrity, like doing your own work sort of thing. There's also counseling, psychological services, disability, military accommodations, discrimination and harassment, and more. All these policies are in the syllabus. Make sure you pay attention to all those and refer to it in the syllabus in Canvas. Okay. I don't want to talk too much about them because I'm trying to keep this video short, because we have a whole lecture to go through too, other than introducing this course. Anyways, the other things is like we have computer requirements. It's standard campus requirements. The technical requirements is in the syllabus. Towards the end, there's a link that you can test your computer. You probably want a webcam if we meet, so we can like see each other, you know. Also with that, you'll need a speaker and microphone, so you can actually talk through Zoom. That is assuming that we meet. Other than that, like, really you have to be this isn't a very computer heavy course. I mean, like, you'll be using your computer the whole time, but the system requirements aren't super intense. Okay. Most of the stuff you'll be doing is either in RStudio or and then everything else you'll be doing in Canvas, which is cloud-based. So good internet, a good internet is going to be helpful to you. All right. So in a normal week, you're going to, there might be an announcement. There's going to be text in Canvas that will always be available. There's a video lecture that will be posted at 8 a.m. Eastern Standard Time on Monday, if there is a video. Sometimes I don't think there's a need for a video, but most weeks there will be a video. And the lab will be posted at 12 a.m. Eastern Standard Time on Monday. So when Monday begins in Eastern Standard Time, that's when the lab's available. The lecture will be available at 8 a.m. There will be links in Canvas. You can also, I mean, like, you're watching it now, so you could subscribe, get notifications so that you can be notified for when it's posted. It's up to you. It'll be, the goal is to have it available at that time pretty consistently throughout the week. And I go through different things like I am today. Okay. As for the labs, the goal is to practice material that week. I encourage you to read the material and watch the videos before you do the lab, not do the lab and then like look back to the reading. It's intended for you to do the lab after you do that stuff. So when you're reading the material, read the material, watch the video, like kind of practice along so you know how to do what we're doing in both the reading and in the video, and then do the labs. It'll make the lab go way faster, I promise you. Anyways, the point of the lab is to practice the material covered for that week. So you're going to be graded on correctness, and the grading might take a week. It takes time to grade these things. We look at everybody's answers, and one of the things that we do is we will grade your answers based upon other answers that you have, right? Let's say that you make a mistake early in the lab. Oftentimes, if you don't have the same answer that we have to, it could snowball out of control, and that means that you have a really, really bad lab, even though you just made a simple mistake in the beginning. Doesn't mean that score isn't representative, right? And so we work really hard to make the grade for your lab as representative as possible, both thinking about our own time constraints and that sort of thing. There's lots of things that go into the grading, is what I'm trying to say, and it could take us time. We try to get it back before the next lab is due. Things happen, and I'm sorry. If you have questions about the process, please ask. But when we release those grades, there is feedback that's provided as to where you made mistakes. If you need more help, please don't be afraid to ask, okay? And like I said, the grades are based off of previous answers. So if you make a mistake in the beginning, make sure try to get everything as right as you can, but we will be grading you on that earlier answer if it uses that earlier thing. Like if it asks for a mean at the beginning and then uses that mean later on for other calculations, we're going to be basing those other calculations when we're grading your work based upon your earlier mean. So make sure you're as consistent as possible. I mean, try to be as correct as possible, but if you make corrections on that mean, make sure you go back and check on it. Make sure you also complete the lab in one submission. When we're grading it, we don't see like how far you got in one and how far you got in another. We allow unlimited attempts, okay? Because things happen throughout the week. We get it, but we like just make sure you try to do everything in one submission. It makes our grading process that much easier, okay? When people don't do that, it makes the grading process that much longer, okay? And again, if you have any questions about our grading, or whether it's the process, or if you're confused as to how it's not something that you had or something like that, please don't be afraid to ask. Okay. So let's talk about the tools that you have at your disposal. So first of all, Canvas. Canvas has like stuff about everything that you need for the course, right? Zoom, that's how we meet. YouTube, that's what you're watching this on. The Office Suite, you're going to be doing the first lab in Excel. So you have that. One of the nice things about being a Penn State student is that you have access to that material. R and R Studio, we'll be doing R and R Studio. I think technically this class has you using it a little bit later. But I'll go into, in the next slide, it has like how to install R or how you can use it. In just a second, but the idea is you'll be using that for pretty much the whole semester, sans the first week or so. Some things that might also help other than other YouTube videos, but there's also LinkedIn Learning. Being a Penn State student, you have access to LinkedIn Learning. So if you look, do even like a Google search for LinkedIn Learning PSU, it will have a link where you can log in with your Penn State credentials and have access to LinkedIn, which can help you with statistics, programming, and it can be used for all sorts of things. I've used it for learning Photoshop and all sorts of other stuff, but it has a lot of computer help in it that you can use. It's pretty sweet. Give it a shot. So anyways, in Canvas, we have directions for how to install R. Your best bet is going to be installing it locally. You don't need to do it this week. I encourage you to try to do it ASAP, and you can send questions if you have them. We'll try to help you the best that we can. But the idea is like you want to try to install it on your computer. Now, first thing we have to do before we talk about I've hinted at it. There's a difference between R and R Studio. So R is the language. R Studio is what's called the IDE. So the idea behind the IDE is that we use the let me just use it in R and R Studio. We use R Studio to work with R. Okay, R on its own, it's going to be kind of working like a calculator. You know how like where you like say 2 plus 2 and then enter 4. All right, 4 to the second. It's like it does those sorts of things. I can do line by line by line. One of the things about R Studio is that it incorporates other tools like scripts, so you can do multiple lines of things, and you can it's way helpful. So you want to install both of those, but in order to be able to use both of them, you have to do them R first and then R Studio, and everything's going to be easiest to install it locally. That means on your computer, and that's what I heavily recommend. So first install R. There's directions and links in Canvas to do that, and then once you do that, install R Studio, and make sure like from then on you will interact with R Studio and it will work with R through R Studio. Okay? If you're new to the whole programming thing, feel free to ask questions if you need to, but that's how it works. Hopefully that's helpful. But if for some reason something happens throughout the semester and R Studio for you acts up, or you are like your computer acts up and you need to borrow something else, you still have other options. These other ones here are cloud-based. So WinLabs, being a IST student, you have access to WinLabs. There's a link for that. There's PSU web apps, or at least there were. The idea is like there should be links for all of these as other options. They're not as good because they are cloud-based. There's going to be some lag. You're going to definitely need an internet connection. When you're doing R Studio, that's installed locally on your computer, and you don't need internet for working on that. So can't emphasize it enough. Make sure you're installing R&R Studio locally on your computer when you can. If something happens where you can't, you have those other options as options. Okay? All right. So now that we've introduced the class, the tools that you need, let's start talking about our first lecture. Okay? And this is the foundational stuff. So a lot of this, most all of this stuff that should sound familiar because a lot of it is pulling from Stat 200. But we're going to re-emphasize it to refresh and to make sure that we're all on the same page on this stuff. So let's begin with variables. So we're going to talk about two different types of variables, independent variables and dependent variables. They have different names. Like for instance, independent variables are sometimes known as predictors, and dependent variables are known as outcomes, right? So the idea is like oftentimes we're looking at independent variables to see if they can predict things that happen with the dependent variables, right? That's a lot of what we're doing this whole course. And the one thing that we're not doing is causation. Causation in statistics is a very slippery slope. We don't say like this causes this. We can notice that things happen and then something else happen, for relationships happen, right? So like as the, when we're talking about with students, here's an example with students with studying, right? So say we measure the amount of time study versus the grades, right? So grades would be the dependent variable, amount of time studied would be the independent variables, right? And so the idea is we're probably looking for a relationship between the amount of time studied and the grades earned, right? Really, like what we can do when we find this relationship is that we can say like the more you study, the better your grades get. We're not saying that that's causation. We're saying that there's a relationship between that happening, and that makes sense, right? Because if it's not, you can study a bunch. Maybe you study the wrong stuff, right? Maybe you're not as efficient as somebody else, or somebody else is not as efficient as you with the studying. So spending more time doesn't necessarily mean that you will get a better grade. So it's like causation's not really a thing, but we can maybe still show that there is a relationship, and that's what we show. But the thing that I want to point out is that causation's not something that we will be pointing out. So be very careful about your use of the word. Okay. The next thing is variable classification. So we have categorical and continuous, okay? And they kind of fits into a spectrum of, the text talks about a spectrum of accuracy sort of thing. That should make it a little easier to see. So with the categorical, we have nominal and we have ordinal, and continuous we have interval and ratio, okay? The idea is categorical are the categories, and continuous is really more of measurements. I'm not going to say that one is numbers and the other is not, because that is going to be crazy misleading, because there are numerical categorical values like identification numbers. Those are categorical. It's not a measurement. It's a categorical variable. So anyways, let's talk about like what kind of each one of these is. So nominal, these sounds like name. That's how you can think of it, right? So like think about like colors. So we have red, orange, yellow, green. They're just colors. Or like think about like names of soda. We have Pepsi, Coke, Sprite, 7-Up, like all these different things. Those are just names, right? Definitely not measurements. We might be able to like sort them in ways that kind of make sense, but it's just names, right? That's what they are. And it's just that's what they are, right? Then we have ordinal, and those are another type of categorical variable. And like one thing that I always think of is like with horse racing, or with any sort of racing, I guess, is that when you think about like how things are placed, that's how they are. So the thing about ordinal is that it's a ranking of categorical things. So there is like one thing can differ from another, and it's other than just name, right? So there's a difference between first place and third place. There's like a definite order that comes in ordinal, right? But something to kind of point out is that if we're thinking about racing, the first, like if you think about the gaps in times between first, second, third, fourth, so on and so forth, it potentially inconsistent, right? And that's like kind of one of the points about ordinal variables is that it's just saying that's that value, that's the next value, that's the next value. It's just that ranking. It doesn't say anything about the distance in between. And so we want to be very careful about how we differentiate those, right? Continuous, that's when we get into those values in between, right? So then if we think about like finishing a race, the racers, the time that it takes them to complete the race, those are continuous values, right? It would actually be a ratio is what that value would be because there's a absolute zero for it. So the difference between the two continuous values are interval and ratio. Interval, there's not a absolute zero. Ratio, there is. Okay, we don't emphasize this too much past this lab because the idea is like it's not really as important. It's like we have continuous and we have ordinal and nominal is really how a lot of the semester is going to go. That's where you want to put your emphasis on for these things for the whole semester. But the idea is like there's a distance between, like a set distance between like those different things. So like example that's used in the text is temperature, right? So when we're thinking about either Fahrenheit or Celsius, you have like 32, 53, 21, like all those are different values. And it's like pretty consistent between each of those measurements, right? It's kind of, think of it continuous values as being measurements, right? But also notice that there's a zero in both Celsius and Fahrenheit. It's an interval because it doesn't have an absolute zero. Zero is not the bottom of the thing. When we talk about Kelvin, that's considered more of a ratio because there's nothing, there's not a lower temperature than 0 degrees Kelvin. Okay, so that's kind of the difference. It's kind of weird, and it's like I said, we don't emphasize it super much, but there's the differences. So the next thing that we're going to be doing is describing data. And we can describe data with shape, central tendency, and variability, right? So once we have data, we want to know stuff about it. And that's very common. You've been exposed to this before, but the thing is like we're emphasizing like these different things that kind of help describe the data. So shape, how the data looks when it's graphed. Central tendency, what things typically are. Variability is the spread of the data. Let's talk about each one of those. So first of all, shape. First thing we'll look at is skew, right? You've heard this before with negative skew where things are skewed to the left, and we have positive skew where things are skewed to the right. Notice that it's not where the hump is, it's like where that tail is. That's where the skewing is. The next shape that might be kind of new to you is kurtosis. And we have these two here that I'm probably going to butcher if I try to say them out. But the idea is it's thinking about central tendency and variability, right? Or maybe it's pretty much just what variability is and how it affects the central. Anyways, let's give it into examples. So the idea is when we have things that are have like strong positive kurtosis, it means everything is that central tendency and there's not that much variability. When we have negative kurtosis, it has extreme spread in data, and the central tendency means very little. And so when you need like a little bit of both of these to kind of have like do stuff. Let me give you an example of like where it kind of makes things upsetting is when we're thinking about ages of students in elementary schools. Okay, let's first start about kindergarten. So there's a certain age when people join kindergarten. Now, keep in mind, not everybody is in kindergarten, but it's around 6 years old, right? But there's not too much variability from that age. So in that case, it would be we'd have very strong positive kurtosis for that because everybody's pretty much 6 years old or not too far from it. Whereas if you think about the negative kurtosis, that would be like if we looked at a elementary school where there's pretty much the same amount of kids in each grade, right? In each grade, they are about the same ages in each one, but what that would mean is like, so in kindergarten, they're pretty much all 6. In first grade, they're pretty much all 7. Second grade, they're all 8, so on and so forth, right? And so if you think about like how that spread works with the measurement of their age, the central tendency would be whatever the middle grade is that we're looking at, right? But it's not really representative of the data because there's so much spread in what's available that it's not really helpful. The thing is that neither of these are very desirable, but it could mean some adjustments if it's positive kurtosis. Okay. Another thing that could happen is that there could be multimodal, like bimodal, where there's multiple humps in that thing in the graph. Okay. Anyways, let's move on to normal distribution. So normal distribution is where it's symmetric, so that means it's not skewed. Unimodal, one clear peak, and it's asymptotic, meaning that it kind of approaches 0. Now the thing about normal distribution is that it doesn't really happen in real life. I mean, like we use it so much, but the thing is, it's like things act normally distributed. So then we're saying, all right, so if we assume that it's normally distributed, what do we know about normal distribution? And then we apply those things to it. Okay. But nothing is exactly normally distributed. It's just whenever we say something's normally distributed, we just say that it's close enough that we assume that it has those properties, right? And so the great thing about that is then we can think of like percentages of people or whatever usually it's people, of things that we're looking at to understand how things vary. In the lab that's coming up, we'll be using it for prices and stuff like that. So it's something that we'll go into even more detail later. But I just want to tie that into things that we're talking about now. Anyways, next thing, central tendency. Central tendency is something that is used tons and I think overused sometimes, and that is the mean, right? A lot of times, and this is also me being a teacher, a lot of students really value the average grade or the mean of assignments, but it just it doesn't really tell you that much. It just says this is what things tend to be. So if you think back to the example that I had before where we're talking about the ages in an elementary school, notice that spread was so huge that it kind of doesn't matter. That's just the mean is the mean. It's calculated correctly. That's what it is. But it doesn't really say that it's like the thing that happens the most. Also, another thing is that mean doesn't always make sense for what we're talking about, right? So let's say, for instance, in this class, I hand out like pieces of paper that are different colors, right? So I have a blue one, a red one, a purple one, something like that. And I have like 4 different ones, and I hand them out randomly to people. And for some reason, we want to know what people typically get. Mean doesn't make sense for that because that's not a thing that we would measure mean with. That's more something that we would use for mode, thing that happened typically. See, the thing is, it's like mean and median, mean doesn't make sense for everything. So just be careful about how you use it. Median, careful about how you use that one too. But the idea is it's the centralmost score. So that means if you order everything up, that's the middle value. That's the median. Okay. Sometimes when we're talking about what's typical, that's what central tendency is. One of these might make more sense than the other. Okay. That's really what we're talking about. Okay. Variability. Variability is when we're talking about like thinking about the spread of the data, right? One thing is range, which is the highest value minus the lowest value. We also have the deviation score, which is a value minus the mean. We have the sum of squares, which is the sum of the squared deviation scores. And the variance is that divided by the amount of things that we're looking at minus 1. And we have standard deviation, which is the square root of that. Okay. Oftentimes the variability or the variance in the standard deviation tells you how much things are varying. So like, for instance, when we're thinking about that normal distribution, the 1 and the negative 1 and the positive 1, those are standard deviations. That's kind of like thinking about how things spread out. Okay? It's important stuff because once again, if we're thinking about the scores in the class, if we assume that the class is normally distributed, we can't, if we know what the mean is, that's just telling us what people typically got. It's not saying how close, it's not saying everything is kind of close together, even though when you're not asking for standard deviation, I feel like that's what you're looking for. But the idea is we also need to know the spread, because there could be some people that do super well. There's some people that didn't even take it, right? And they could get 0. So it's those things affect it. And so it's just things to keep in mind. Okay. Anyways, let's talk about the lab. And this tip will help for all labs in the future, right? The idea is we'll be, and see, the thing is in labs, you're going to be given data. Okay. It's going to come in different forms throughout the semester. But the idea is as we get that data, something to know about it is the information about the data. And so it's important to go through that at the very beginning. I introduce things, and it's important that you read them, because otherwise you can make a mistake. Let me give you a point. If you look at the, let's see, family, let's see, where was it? So I was looking at things, so then go to family size. So family size, look at it. So when you think about just without looking at this, I don't know, I said just to look at it, but okay. So family size, you think about that's some integer value, right? So 2, 3, 4, 5, something like that, right? But if you look at the description of the data, it's saying that it's either small, medium, or large, right? So initially, just looking at the title, the name of the value, it looks like it is a ratio, right? Where there, I guess, could be a absolute 0. But really here, it's actually an ordinal value, because it's either small, medium, or large, right? So it's very important that you read the data description at the very beginning, okay? Not just this week, all weeks. All right, let's talk about what's due for this week. Make sure you read the academic integrity. Make sure you read the rest of the syllabus. There are 2 readings that are in Canvas that you need to do. One is variable types, the other is describing data. I covered a lot of stuff. Hopefully that helped. Things to complete: academic integrity acknowledgement, academic integrity quiz. There's also a Canvas quiz, making sure you know how to use Canvas. And then also make sure you do the lab 1 for next week. I also recommend that you try to install R in R Studio, so that if you have questions, you can get those answers, so that when it's time to actually use R in R Studio, it's already installed. Okay? And ready to go. Anyways, I think that's it. So hopefully that helps. See y'all next week. Bye. Hey everyone, hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message to both me and the rest of the teaching team in Canvas, and we will get back to you as soon as possible. Don't send it through normal email, you will not get as fast response. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for the next video. Anyways, I think that's good for now. See y'all later. Bye.